All right, guys, complete the do now on the board, please. Did you guys turn in the activity from yesterday? Raise your hand if you did. I only have one. You were able to see your draft? A little bit. You're going to have to take it back. The graph, so what you're going to do to complete the graph, and I'll try to give you time at the end of the period to do this, is you're going to open Cami, then open the document through Cami. All right? That'll allow you to go ahead and draw a graph on it. All right? All right, guys, so reviewing from yesterday, we talked about 4 layers, right? And you guys got a bit of information about each of those layers. So who wants to give me one layer and describe that layer for me? Noah?
The mantle. It's a semi-solid liquid because of the heat of it's not enough to melt it fully into a liquid, and it's still semi-solid.
Very good. It is a semi-solid. Remember, we compared it yesterday to the slime. All right. Remember, it's malleable. And again, good point that you brought up. Is the temperature high at that point. So, is it metal? Is it rock? What is the mantle made up of? Melissa, you remember? It's molten rock, right? So again, the upper layer, which is the what? I want to give you the answer. What? The crust. Good. So the crust, solid rock. The mantle is made up of soft rock. All right. Now brings us to our last 2 layers, Melissa. The outer core. What can you tell me about the outer core? It's a liquid. Good. And what is it made up of? Metal. Does anybody remember the 2 metals? Iron and nickel. Iron and nickel. Good. And we only have 1 layer left. Joffer. The what? What core? She just described the outer core, so you would be describing the inner core. Yeah, it's a solid ball of metal, again, iron and nickel, and the only reason it is solid is because of the high pressure at that point. Good. All right, so what are some changes that occur as you go from the crust to the core? What would be some of the changes you would experience? Jeremy, you got anything for them? No. Arlene? Yes, it would get hotter. So the temperature increases. Good. What is another thing that changes? And you basically just said it. You just gave the answer before when pressure increases. One last thing increases. What if I told you mass divided by volume? What would I be talking about? Density. And density also increases as you go from the crust to the core. So what I want you to do now is I want you to go to Google Classroom, open up the Earth Layers notes. Now, while you're doing it, does anybody know the name, not the specific name of a scientist, but the type of scientist that's responsible for studying the forces that make and shape Earth? They study mountains, they study earthquakes, they study anything about the planet. What would those individuals be called? A geologist. Very good. So therefore, geology is the study of those forces that make and shape the planet. So this is your first slide. You should be copying this down. Everybody get that? Good. So just a reminder, once you're done copying a slide down, just close your Chromebook halfway. That I know when I see everybody's Chromebook in that position, I may move on. All right, so my question for you is, yeah, we know that there are 4 layers of the planet, but how did they find this out? When the deepest mine is only a few miles deep. So how do we know that there's an outer core and an inner core when we can't even get that deep? Anybody want to venture a guess? Melissa? You don't know? Right, so pay attention to this video then.
You can can learn a lot about the world by looking at a globe. It shows the continents, the oceans, the locations of mountains and other landforms. But a globe can show you only what's on the surface of our planet. Have you ever wondered, what's inside the Earth? Nobody has ever been to the center of the Earth, so how do we know what's there? If you bounce a ball while standing, the ball will return in about a half a second. But if you kneel down, the ball returns much more quickly. You can figure how close you are to the floor just by measuring the time it takes for the ball to return. This is the same principle scientists use to determine what's inside the Earth. But they don't use balls, they use explosives. When an explosion is set off near the Earth's surface, it creates shock waves that move toward the center of the Earth. When the waves strike certain objects, the waves bounce off, returning to the Earth's surface, where they cause vibrations which can be measured by machines like this. By studying these vibrations, scientists are able to learn a lot about the materials that make up the interior of our planet.
All right, so now they just told you how scientists have been able to determine the layers of the Earth. So, can anybody tell me what they said? Noah?
The vibrations from explosion.
It's the vibrations from explosions. Good. So they did a good demonstration in that video where basically they simplified and explained it with the basketball, right? So I know how far I am away from the ground depending on how long it takes for the ball to come back, right? The higher I'm bouncing the ball, right? The higher my hand is, the longer it takes to come back. The closer my hand is to the floor, the shorter amount of time it takes to come back. So that tells us how deep a certain layer is by monitoring those waves. And the waves that are produced by an explosion are called seismic waves. Has anybody ever heard of that term, seismic waves, before? Earthquakes. Earthquakes produce seismic waves, all right? So they use those seismic waves. They use radar. They send the seismic waves down. Depending on how long it takes for the seismic waves to come back, they're able to determine how deep that layer is. But how are they able to determine that there are different layers? And it's because the waves, they bend. So you're going from, remember, you're sending the waves through the solid crust, right? And then it hits the soft, gooey material of the mantle. Well, what that causes the wave to do is it causes the wave to bend. When I see that wave bend, I know I've hit a different consistency of material. When it gets to the outer core, which is completely liquid, bends again. When it gets to the inner core, which is a solid ball of metal, it bends again. So that's what allows me to determine I have those 4 distinct layers. All right, copy this down, please. All right, so you're not done with this slide yet. Let me just slide it over. Okay, so do me a favor. I just want to get a show of hands. Who still has to complete the graph on yesterday's activity? All right. Good. All right. Okay, again, so here is a model of the planet. And if you can see from this diagram here, what is the thinnest of all the layers? The crust, right? And the crust, basically, if you would take an apple, cut it in half, and you know how thin the peel is, that would be a good representation of the Earth. Because again, the white material of the apple would be the mantle. And then remember, in the center of the apple, you have the core, which contains the seeds, right? That would be analogous to the core here. So it's a good comparison with the sizes of the different layers. All right, so 3 things, we said it before, that change as you go from the crust to the core. What were they? Come on, you said it before. What were the 3 things that increase as I go from here down to the center of the planet? 3 things. We just said it. Arlene. Temperature, pressure, and density. Good. All right, so who's still copying this down? All right, so to finish again, I'm just going to repeat the instructions for completing the assignment from yesterday, the layers of the Earth activity. Again, to create the graph, you're not going to open up the document. What you're going to do is open up Cami from the extension at top. Then you're going to say open from Google Drive. You're going to go to the classroom folder, the folder for this class, and you'll open up the document from there. This will now allow you to use Cami to put a graph into that document, because you can't put a graph on that. You can't write on that graph because that graph is in there as a picture. Okay, that's why it's not allowing you to write on the graph. All right, but before you do that, what I want you to now do is go to Google Classroom. There is a Google Form exit ticket to complete, 3 questions to answer. Please do that now. Once you've done that and you submitted it, then you can go ahead and finish your graph. Any questions? Okay.